So now I will solve applications on circular motion. But before I will start with circular motion, you all know the position vector of a particle when it moves in circular motion, it will be in the form r equal r cosine theta I plus r sine theta j. This is the form of the position vector in case we have circular motion. In this case, here r is the radius, theta is the angular axis of the point. So x will be r cosine theta and y will be r sine theta. This is if you have to represent it in Cartesian coordinates. Since and in a circular motion, the point M has abscissa and ordinates x and y. Okay, and this is the angle theta described by M, and this is the radius r. So x will be r cosine theta and y will be r sine theta, since cosine theta هي adjacent, which is x over hypotenuse. The hypotenuse here is r, so x will be r cosine theta. Well, y will be, if we use sine theta, it is the opposite, which is y. Here the opposite y over r. The hypotenuse is r, then y will be r sine theta. Okay. ومرق معنا كتير ان احنا position vectors بتاع مثلا 3 cosine 2ti plus 3 sine 2tj. إذا طلعنا the equation of the trajectory, which is the relation between x and y independent of time, we will obtain final equation of a circle. So the position vector in case of a body moving along a circular path or a body rotates around its axis, it is in the form of r here will be 3 and theta will be 2t. So r cosine theta I plus r sine theta j. هيدا الفورم للposition vector in case عندي rotational motion or circular motion. Now application 1 about the circular motion. We have an object moving along a circle. The radius r equal, for example, 1 meter, and the angular displacement for the particle is 80 squared plus 40 plus 1. First of all, we have to determine in the part 1 delta theta between two instants 0, 1. Okay, delta theta is the angular displacement. It's always theta 1, theta initial minus theta final minus theta initial from the interval and 0, 1. So theta 1 minus theta 0. We substitute for 1 in theta. We obtain 8 plus 4, 12, 13 minus, we substitute 0 for the time. We obtain 1. So we get the displacement would be 12 radians. Okay. Part 2, we want to determine v, the linear speed. Since v will be r theta prime and will be r, نعمل derivative للثeta نحصل على 16t plus 4. At any time the speed will be, will r we substitute it for 1 meter, we get 16t plus 4. This is v. هلا what about the part 3? the أكيد هون type of motion ما بيطلع uniform circular motion لأنه theta is not constant. It varies with respect to time. It is a function of time, so it is not constant. So motion هون is not uniform circular motion, بتطلع uniformly varied circular motion. بس هي مش مطلوب منكم ال time equations than uniformly varied circular motion. So what about theta w prime أو at? At will be r theta w prime, and theta w prime with derivative of theta prime يعني 16t plus 4. It will be 16 radian per second square. Here 6 radian per second for the theta, وهون أكيد meter per second for the speed. So it is 16 radian per second square. Then at, the acceleration at, if we part 4 we need to find the acceleration. At will be r theta w prime بس بضربها ب r تطلع 1 times 16 بتطلع 16 بتصير meter per second square. عم بحكي لها SI units. So in part 5, what about the acceleration? Normal acceleration an will be v square over r. We substitute for v square 16t plus 4 square over 1. It will be 16t plus 4 square. So if we have to determine the acceleration, which is radical at square plus an square, we substitute for each value of them. So another application, if theta now 2 equals, for example, 2t plus 4, with the radius of the circle performed is 2 meters. So what about in part 1, if we have to determine the type of the motion, or v, the linear velocity, the linear speed. The linear speed v equal r theta prime. R is 2 theta prime. We derive theta with respect to time. To t, its derivative is 240 and 94 meter per second. So it is constant, theta prime constant, and the motion uniform circular motion. What about if we have to determine the angle described by the particle during a certain time t equal 2 seconds? During the 2 seconds motion, delta theta, what will be? So since the motion is uniform circular motion, we can use delta theta equal theta prime t. Theta prime t, we have theta prime here calculated, it's 2 radian per second times t, which is 2 seconds, we obtain 4 radians. So the angle described by the particle during 2 seconds, it will be 4 seconds. Now, what about if we want to determine the number of revolutions performed by the particle during this period of time, delta theta? So we have n equal delta theta over 2 pi. We have here 4 over 2 pi. We calculated, we obtained the number of revolution. بس بتكون number of revolution ما إلها unit لأنها number. هيك إذا نطلع number of revolution, the same way we can determine the frequency, which is theta prime over 2 pi. Theta prime, it is 2 over 2 pi, multiply frequency 1 over pi, and the unit of frequency in SI is hertz. What about the period or the time taken to complete one complete revolution? هي 1 over frequency, يعني هي 1 over pi بتطلع pi. In SI it is in seconds. Okay, this is the period and this is the frequency of the motion of the uniform circular motion.